Hello, good morning to my lecturer, Sir Salty Hizani, and my fellow friends. Today, I, with my team, will be presenting the rate of change in engineering mathematics 2, DBM 223. So this is my team, me as Daniel Wong, 05 DPU 22F 1002, Ernest Hesley bin Julir, 05 DPU 22F 1007, Muhammad Izwanuddin bin Rushidi, 05 DPU 22F 1016. So this is the content of the table of content. First, we're gonna introduction of differentiation, definition of differentiation, rate of change, calculation rate of change, example question, and lastly, conclusion. Introduction of differentiation. In mathematics, the derivative of a function of a real variable measures the sensitivity, the change of the function value, output value, with respect to a change in its argument, which is input value. The process of finding a derivative is called differentiation. Derivatives are a fundamental tools of calculus. For example, the derivative of the position of a moving object with respect to time is the object's velocity. This measures how quickly the position of the object changes when the time changes.
Definition of differentiation, rate of change. The rate of change of a quantity refers to how that quantity changes over time. Typically, the rate of change is given as a derivative with respect to time and is equal to the slope of a function at a given point. For example, rate of change equals change in y per change in x.
Rules to calculate rate of change. Chain rules method was used to calculate the rate of change. dy per dx equals to dy per dt times dt per dx. It is related to parametric equation. Parametric equation is where the x and y are both written in terms of another variable that is called parameter. The positive value for dy per dx is the rate of increases for y respect to x. The negative value for dy per dx is the rate of decreases for y respect to x.
So this is an example question for rate of change. Each side of a square is increasing at a rate of 2 cm per second. At what rate is the area of the square increasing when the side of the square is 6 centimeters? First, we must use chain rules that dA per dt equals to dA per dl times dl per dt. So A equals to L square. After that, we must differentiate the area, so dA per dl equals to 2L. After that, dL per dt equals to 2 cm per second, negative 1. We have this answer is from a question that has been given. After that, dA per dt equals to 2L times 2 cm second, negative 1. So the final answer is 2 times 6 cm times 2 cm second, negative 1 equals to 24 cm square second, negative 1.
So this is the example question of rate of change. The question is variables x and y are connected by the equation y equals to x power of 3 minus 5x square plus 15. Given that x increase at a rate of 0.1 units per second, find the rate of change of y when x equals 4. So as we know, dx per dt is equals to 0.1. So the first step is we have to differentiate the equation given. The equation is y equals to x power of 3 minus 5x squared plus 15. After that, we will get the dy dx equals to 3x squared minus 10x. After that, we have to change the x into number 4. Then the last answer for dy per dx is 8. So we have to use chain rule to find the rate of change of y. The formula is dy per dt equals dy per dx times dx per dt. Dy per dt equals to 8 times 0.1. So the last answer is 0.1 units per second.
So this is the last example of question of rate of change. Given the area A of a circle is increasing at a constant rate of 1.5 centimeters square second negative 1. Find 2, 3 significant figures, the rate at which the radius r of the circle is increasing when the area of the circle is 2 centimeters square. As we know, given that dA per dt equals to 1.5 centimeters square second negative 1. So area equals to pi r square. When we differentiate, dA per dt equals to 2 pi r. And we get the dr per dA equals to 1 per 2 pi r. So we use chain rule. Dr per dt equals to dr per dA times dA per dt. So dr per dA is 1 per 2 pi r times dA dt 1.5. So the last we get the answer is 2 per 4 pi r cm centimeter second negative 1. When A equals to 2 centimeters square, the last answer is pi r square equals to 2. Radius square equals to 2 over pi. So r equals to power of square 2 per pi equals to 0.7978. Then the last answer is dr per dt equals to 3 over 4 pi times 0.7978. The last answer will be 0.299 centimeters square second negative 1. So lastly, in conclusion, rate of change in differentiation is very important in mathematics. Rate of change is used mathematically describe the percentage change in value over a defined period of time, and it represents the momentum of a variable. Differentiation allows us to find the rate of change of x with respect to y. Thank you. This is our presentation.